some of these things are just, we couldn't believe that we were seeing them in the software, because it's just oversights, and it's somebody that's not an expert in their field that's combining all this into a process controller. Another plant that we looked at had a separate governor system that did a very good speed control job. But what happened is they had an outer loop control. There's a lot of talk about that in this HydroVision, but that outer loop gave us a megawatt set point that had no dead band. So basically, you had a person that installed the megawatt control system plant unit, PLC, whatever it was, and he says, you know, I want to see 50 megawatts on my meter. I don't want to see 50.1. I don't want to see 49. I want to see 50 megawatts. So they kept stroking the governor up and down, up and down, up and down, with no dead band. So basically, if you know anything about speed control and compensation and droop and governor functions, that actually overrides the governor's droop function, where it contributes to grid stability. It's being driven. It's just a gate positioner. There were big gate positioners, not 500 kW machines. So you know, with constant redirection, the governor became a gate positioner, and if we separated the governor away from the plant controller, we confirmed that it does operate like a governor. It will correct and for systems disturbances and do the way it's supposed to. So one of the things that we had to do was train dispatch and the programmers of these unit controls that there's going to be some small movements around your 50 megawatt or your 100 megawatt set point, because the unit is going to respond to system disturbances. So you know, there's a dead band that you have to expect to see. The biggest point of the paper is just please consider the application experience. Some of in the paper I joke about, you know, you can have somebody that has 50 years experience at the potato chip plant or the Twinkie factory, and they do a great job at automating soup cooking and whatnot, but you know, they might not know as much about governor speed control or excitation. So the expertise is here and available. You know, just consider using those people. Some of the things that we've learned, some of them are governor specific, but installation, commissioning, testing, maintenance is simpler with discrete systems. You can kind of disconnect and not worry about those other systems and focus on this specialty, this application. One of the old reasons that they gave to consolidate all those different specialties was it's too hard to get each box to talk to each box. There's communication difficulties. That doesn't really apply anymore with universal communication. Almost any box will talk to almost any box. It's new. Every one of those specialties that I had on the first slide, they have years of application-specific experience. You know, Johnny has years of arc flash and safety experience. That resource is available. When you combine, another point that we've discovered, if you combine these systems, even with different rate groups and instructional programs, you're still sharing resources. You almost have to share resources. If you have separate systems, and these are governor specific, but you know, the point of the paper is the expertise. So this would be excitation lessons learned. They have a whole set. We have a set. Protective relaying has a set of things, but governmental performance is not compromised by the processes. Future expansion will not degrade performance. That's another thing that we've discovered. You may have something that meets, that's tested and meets NERC and FERC reliability and also performance standards, and then 5 years later you add 1,000 IO points to that system, and all of a sudden the speed's not there to do what it was intended to do when it was originally tested. Standalone governors always meet NERC FERC reliance, reliability and performance standard. That's what they're designed to and will always meet. So the point of the paper is just, you know, there's technical expertise available out there in all these different specific areas, and they even with young people, they still have years and years and years of specific application experience in their field. They know their field very, very well, and don't just trust your system or your units to somebody that knows a little bit about this, and a little bit about this, and a little bit about this. Any questions? Do we have trends one way or the other, opinions? Do you see that? 10 years ago, we saw separate systems kind of merging into one system, and for the past 3 or 4 years, we're starting to separate back again. So I just, in the industry, what do you guys see?
We had too much fun last night.
Thank you.
Thank you.
Excellent.